Hi, so what am I doing out in the tail end of winter, out in the middle of nowhere? Stay tuned and find out.
Hi, Doug here with DJD Labs. And if you haven't guessed it already, today we're testing train horns. Now if I were to put a list together of all the different horns that are available, which ones would I pick for my test? I'd probably want a real locomotive horn, something like a Nathan K5 La. Probably want a Klein 730. Probably want to get some triple chime horns, the ones you see everywhere. Probably get a few of those. Get a couple quad horns as well. All about the ones on top of big rigs. Wait, scratch that. The big horns on top of big rigs. We'll get a set of those, maybe some other smaller ones as well. We're probably going to want some medium horns, some small horns, some fun horns, some boat horns, some odd horns. Get a motorcycle horn. And we can't forget a Dixie horn. Always wanted to play with one of those. And if you notice beside me, those are the exact horns we picked up for today's test. And if you probably already noticed, today's test is going to be big. Now to give you a quick rundown of what's going to be going on in today's video, first things first, we're going to open up these boxes and see what's all involved in each one. Then we're going to be heading out to a field I booked in the middle of nowhere with some high quality equipment to test the true output of all of these horns and see if they hold up to the manufacturer's claims of being the loudest horns. And then we're going to head back to the studio to crunch some numbers and see which one really is the loudest. But before we get into all that, let's get these boxes opened up and see what we're working with. Here is the AHB4 bullet horn from Horn Blasters. In the box, we have the horn, some instructions, and some mounting hardware. The horn itself unpackaged here. For its size, it's actually quite a nice little horn. These are all metal. It's a metal frame, metal chassis. I'll do a quick pan around here so you can see. Here is the front of the 4 trumpets. There's the side, and there is the back of the horns. Here we have the Klein model 730. I picked it up with the Master Blaster kit, which I will cover here in a moment. But first, let's get this box opened up. I have a cardboard piece, and these are actually quite interesting looking. Let's see if I can't start pulling these out. Here are the mounts for the horn. These are nice, actually all metal with a rubber insert gasket on the inside for holding the horns, which I'll get into those in a moment. So let's pull out this entire piece here, and we have another piece of cardboard and some air lines. So get this box out of the way. This is the front half here. It's 3 trumpets. This one is a wee bit crooked. Here it is from the top. I'll get that on camera. And here it is from the back. So again, this is the Klein 730, and this is the way it comes from Klein. So it comes with, this is the standard kit as you buy it. It comes with a single 1/2-inch port where you attach your valve, and it's already plumbed together from them, ready to rip. Now what's the Master Blaster kit all about? Well, this is an upgrade which allows the horn to be louder. So what that gives us is these 2 valves, plus the third one that comes with the stock kit. So you combine these 3 with this kit, and you actually put 1 valve at each horn. You plumb it in with all 1/2-inch line. This allows the horn to be as loud as possible. This is where they claim to have one of the loudest horns. So when I do the field test, I'll be connecting the Master Blaster kit to these horns to make them as loud as they're possibly capable of producing. Here we have the AH-S4 shocker horn from Horn Blasters. Get this guy opened up, all out of here. So here's one of the horns. They're intricately packed in here. Here's another one. Another one. Another one. That's a 1/2-inch line here. Smaller air line. We got instructions catalog. The box never ends. Valve, fittings, some more paperwork, for sure, and that is everything in that box. All right, so first things first, we have the 4 horns. These are all plastic bodied. Looks like to be a high strength ABS. They all have a mounting tab, 1/8 inch NPT, and then we have a smaller threaded front for mounting. So nice part about these horns being broken up is you can separate them in your vehicle. You can have two in the back, two in the front, or you can mount them all facing different directions. There is down the trumpet itself, and then I'll flip it over. There's the back side of the horn, and then the fitting. Here we have a valve. This is a model SV6615 horn blaster, 1/2 inch valve. So we have a 1/2 inch MPT push to connect straight. There's two of those. And then we have a breakout one. This allows you to run a line to each individual horn. And then each horn itself will receive one of these right angle fittings to connect in to this line here that will allow you to connect up all your horns remotely, close together, or however you feel needs fit. And then on the valve side of the horn, you can mount the 1/2 inch DOT airline here. It actually says hornblasters.com on it. That's pretty slick. So nice actually long length of line with this guy to, again, allow you to mount them in any location you want. Here we have an interesting horn. This is the Redneck Special from airbagit.com. This is one of the longer horns I have here for testing. And then we'll move on to the horn itself. I'll try to get out of the box here. So here is the horn, covered in styrofoam. This is actually quite a long horn. I believe this one is 48 inches long, or almost 4 feet in length. It is all metal, and it comes with a nice mounting foot. There is a seam under this foot, I noticed when I was originally unboxing it to check for quality control. And we come out down to the end here. You'll see it has a right angle, looks to be a 1/4 inch MPT valve that then comes to a 1/8 inch MPT female port with about 5 inches of wires to connect to your 12-volt system. Here we have the Maximus quad horn from trainhornkits.com. And there is a lot in this box, so let me start by pulling all the pieces out first. So we have the horn, line, wire, hardware, relay, and basket. That looks to be everything in that box. Next, we have a relay here with included wiring harness. And see, it is a Bueller 12-volt 4060 amp relay. And yes, it looks to be also socketed. So there is the relay. It actually comes with wire for mounting up the relay. Actually a good length of it. Looks to be about 16 gauge or so. And here we have the airline. Let's see if this is marked. It is nylon. It is 1/4 inch. It is DOT. This is some nice quality line. There's also a good length of that included as well. And this hardware kit comes with all kinds of stuff. See if I can cover all that here. And then we have a illuminated rocker switch included in there. So this is 12-volt AC power and ground for connecting. We have our standard hardware. And we have, I don't think there's a brand name on these. There is not. We have some push to connect fittings for the 1/4 inch line. And they actually give you all the wiring parts you need, all the crimp connectors for connecting to your battery, as well as connecting to the relay. They give you all the spade connectors. They even give you butt connectors here for connecting your wires into your existing wiring harness. So there is a lot included with this particular horn. So here is the front trumpets. And they are all metal, as well as a metal construction and metal backed body. There is the side of the horn, and there we have the back side. And I do apologize, I have styrofoam all over everything. Here is the valve itself. It is a right angle, 1/4 inch MPT to 1/8 inch NPT 12-volt solenoid valve. The nice part is they do give you the included fitting to go to 1/4 inch, so it's all ready to go for you. And the horn itself is quite heavy. Again, it's a little bit thinner than 1/4 inch, all steel bracketry holding this guy together. And here we have this monster. This is the Nathan K5 LA. I got this one from Horn Blasters, but it is a Nathan horn. So let's go ahead and get this guy opened up. It's basically the grandfather of all locomotive horns. Wow. All right, I can't lift this out of here. Oh, yeah. This thing's got to be close to like 30 pounds. This is the Nathan K5 La Air Chime. This is basically the ones you see on top of trains when they go by. This thing is all cast aluminum. It is quite solid, quite industrial. Before I get into the horn itself, I just want to have the camera zoom in on these guys. It comes with two 1/2-inch MPT SMC push-to-connect fittings for connecting the horn to your system. One thing that is worth mentioning, this horn does not come with any accessories. There is no valve. There is nothing to connect it to your vehicle. There is a single port here on the bottom that comes with a very large warning that says prior to installing, remove red plug. I don't know why you'd ever do it without that, because you'd never be able to use it. But the supplied fittings will connect into this port, and you'll need to get yourself either a hand actuated or an electric air valve to actually power these horns. So for the test, I'll be using a manual valve to operate these guys. So when I do the test, I'll take both of these two end horns, flip them around to match the other horns in the series. Here we have the Wolo Cannonball Express from www.wolo-mfg.com. Strong smell of rubber in this box. Pull out the horn, get some airline, get all the accessories out of the box. That looks to be everything. So this is what was stinking up the box. This is a thick chunk of solid rubber located, we'll get the camera zoom in here, on the inside of the box, as well as mounting hardware for the horn. Next up we have some 1/4-inch airline. Does not appear to have any marking on it. It's a somewhat semi-rigid 1/4-inch line. And then we're going to get off to the horns here. Put these out of their plastic. So here is the Wolo horns, the Cannonball Express. There are the front 3 trumpets. And those are all metal, as well as metal construction. One thing, the side, if you can zoom in here, this is actually kind of funny. There is a little picture of a guy showing that hearing protection is required. I find that kind of comical. And then we'll zoom out, and then here is the back of the horn with the Wolo logo on the back side of it. Horns themselves are actually quite heavy. A very thick steel plate on the bottom, a little bit thinner than 1/4-inch. The fitting here is a 1/4-inch MPT right angle air valve, 12 volt. And the fitting on it, I'll spin this around, is for 1/4-inch line. It is a compression style fitting for the line. And again, there's about 4.5–5 inches of wire coming out the back side of it for connecting to your 12 volt accessories. So this is the Wolo Manufacturing Cannonball Express horn. Hey, now that we've gone through what's in the horns, I want to give you some more details before we head out to the field on what this test is going to involve. Now, to record the output of train horns involves some very special equipment. I had to make some phone calls to the Federal Railway and Safety Administration, as well as some manufacturer train horns like Nathan, to find out what they use to certify their train horns. So what I ended up with was this, a B&K Model 2250 sound analyzer. This particular analyzer costs $5,100 just for the analyzer body. Now the microphone element, which I have here, which is the small spot down here in the bottom of the case. This element is mic element 4941 by B&K. It is certified up to 184 dB, and it is required flat all the way down to 4 Hertz. This particular microphone will run you $2,300, and this is the exact microphone that is used by places such as Nathan Air Chime and the Federal Railway Safety Administration to verify the output of train horns is within limits. So to give you an idea of what's so special about these guys, you'll see there's a sticker here on the case of the mic, as well as on the unit itself. This is a North American Service and Calibration Center sticker. This certifies that what this measures is exactly what the output of the horn is. That certification will run you about $760, which basically is valid in court of law stating this is exactly what it outputs. Now, this particular meter will be coupled up and set out into the field to connect to these horns to see how loud they truly are. Now, to move on, I have this guy here. So it may be one thing to be really loud, but do you sound good? That's what this guy is going to find out. This is a Dbx Calibrated Microphone. This particular microphone is, I'm going to get off to the white here so you can see it, is a certified flat recording microphone, which means it's over the entire audio spectrum, it records a flat signal response. I couple this to a real-time analyzer software, and it'll show me exactly what frequency each horn produces and or what note they are produced at, as well as what level. I'll also use this microphone with some very high-quality audio recording capabilities to record a sound sample of each horn with a flat response. So you'll be able to hear exactly what they would sound like if you were there, be it at a greatly reduced volume level. I'll also be using a high-quality phantom power adapter to power the microphone, and cabling and so forth. I also have a laptop out in the field to record all the data too. Now, to give you some details on what I'm going to be using to actually power these horns, Air Zenith was nice enough to donate one of their high-pressure 300 psi rated all-aluminum air tanks. This particular tank is 300 psi rated, but can run up to 600 psi. It has 4 half-inch ports and 4 quarter-inch ports. I'll be interfacing these directly with the horns, for this tank can handle the pressure that some of these horns are rated at. Now, to fill this tank, I will be using a large case-size nitrogen tank filled with gaseous dry nitrogen. Why nitrogen? Well, nitrogen makes up about 78% of the air that you and I breathe. And the nitrogen that's in the tank is certified dry, which means there's no moisture, which means I'll get consistent test results over and over again for each horn. The particular regulator I am using will allow me to regulate between 0 and 600 psi, so I can exactly set what pressure will be inside the tank for each horn's test. I'm going to try to set the tank to the maximum rated pressure for each horn that I'll be testing. And again, I'll be able to isolate the tank down for every single test that I complete. Now, one thing to keep in mind, I have here a small segment of Part 49 CFR Parts 222 and 229 of the Department of Transportation's Federal Railway and Safety Administration guidelines for testing and certifying what a train horn is and how loud it should be. So I'll be following along with these guidelines for my test today. One thing to point out, subsection 222.129 states that your recording device needs to be at 100 feet forward of the knuckle of the train. Now, most standard audio measurements are done at 1 meter or 3 feet from the sound producing device. So for today's test, I'll be using the meter at 2 distances, at 1 meter or 3 feet, and at 100 feet or 30 so meters out from the recording device. So I'll have 2 values for every horn I test. So that's enough talking for now. Let's head out to the field and see what these horns really can do. Hi, welcome out to the field. And if you haven't guessed it, trying to find a location that'll let you test 20 plus train horns isn't exactly easy. I had to make multiple phone calls and a lot of people canceled on me at the last minute once they realized what I was doing. So I'm at a non-disclosed location about an hour away from the studio, literally in the middle of nowhere. We're on a 600-acre farm with no neighbors nearby. So we can test all these horns at their full potential without any worry of the cops being called. Now, to give you another quick rundown of the test, you'll see here I have a cone set up at 3 feet and at 100 foot for moving the sound meter back and forth for each test. I also have 2 tables set up with a power supply and a car battery set at 13.8 volts DC to run each of the solenoids as well as the motorized horns. I also have the air tank and a large nitrogen tank set up with the regulator to power it. And I also have a quick disconnect system to supply air to each horn. I'm using a 5/8 line, which is basically unrestricted to a 1/2-inch port, which then steps down right at the horn within the last 3 or 4 inches using their line. So I'm giving them the best possible chance to be as loud as possible given the materials that the horn is supplied with. So that's enough of the test. One last thing. I do have a calibrated meter located behind me to the right, slightly off camera, that will be recording the high quality sound clip of each one of these horns so you can hear it yourself here shortly. So let's get to the test and keep an ear out and see which horn you like the best. And welcome back to the studio. I took all of today's values, crunched them down, and analyzed them, and got some interesting results. Now to give you the one thing you've all been waiting for, are the results of today's test. So I'll put those up in a chart here beside me. Now while you're looking at that chart, I want to remind you I did all my tests in accordance with the Department of Transportation, National Railway Safety Administration's guidelines. And one thing they're very particular about is the environment in which the values are collected. One of those is temperature. It needs to be between 32 degrees and 104 degrees Fahrenheit. Today's temperature was 41 degrees. Why so brisk? Well, I wanted the temperature to be as cold as possible within that window, for the air is more dense and allows the sound to propagate more efficiently through the air, making them the loudest they possibly can be given the environmental constraints. Next is humidity. Between 20 and 90% is allowed. Today's humidity was 69%. The last value was wind velocity. You're allowed maximum of 12 mile per hour sustained winds, whereas today's results we had 12 mile per hour gusts. So we're at the upper end of what the required window is, which did affect some of our 100-foot results, which I'll explain later. But the chart you're looking at here is all 3-foot results, measured 3 feet from the longest horn. The value you're looking at is decibels in the A weighting, which is similar to what the human ear perceives, which is frequency dependent. And it also is done with a fast response peak. So that value is basically in accordance with Department of Transportation's values that basically all the horns are rated at. The reason I didn't use SPL or go with a TermLab SPL meter like used for car stereo, they have a limited frequency response, and it's also affected on air and environment, where I'm out in this large open field and outdoor environment, so SPL would have been unreliable. So this particular time, I stuck with the DBA weighting, and again in accordance with the guidelines. So you'll notice the highest one on the chart currently is the Nathan K5 La. This really didn't come as much as a surprise to me, for it's a true locomotive horn. And the interesting thing about it is the guidelines state that a train horn needs to be a minimum of 96 dB at 100 foot and a maximum of 110 dB at 100 foot. So when I get into the 100 foot chart here shortly, I'll explain where some of those fall in. What did get me surprised though was the shocker horn from Horn Blasters. This horn, I mean, it was plastic. I didn't expect that much out of it. But for the fact it comes in at 142.8 dB, slightly under the 143.6 of the Nathan, really surprised me. That small plastic horn is as loud as a locomotive horn. The other thing that got me by surprise too was different pressures produce different volumes. So most of the other horns I ran at manufacturer rated output, which produced the loudest possible noise. The shocker I tried at 200 and 145 psi, as well as you'll see in the chart a few other pressures. And I found that 145 psi was the loudest possible rating, which was interesting. A lot of people think the more pressure and more volume you slam into a horn, the louder it will get. We start running into turbulent flow. You start getting into problems with the diaphragm contracting and so forth. All kinds of details that can affect the horn's performance. So one thing to keep in mind is more pressure, more volume isn't always better for a louder sounding horn. So next thing up, I'm going to actually show you a cutaway of a horn and explain how they work. For the mechanics of the horn are what affect what it sounds like, its frequency, and how loud it can produce a sound. To better illustrate why the different horns sound different, as well as produce different volume levels, I have here before me one of the smaller horns out of the Shocker S4 kit. I sent it out and had it sectioned. And we can see what goes on inside a train horn. So to give you a good illustration of what goes on, first things first, the air comes in the bottom through the fitting here. Goes into an open passageway, it's on both sides of the horn. It then comes up and pushes against this stainless steel diaphragm inside. This diaphragm gets pushed back from the air pressure, which then opens up a void and allows the air to pass down through the trumpet and out to your ears. Now, when this happens, it produces a low pressure field inside the horn, which then causes the stainless steel diaphragm to slam shut. When it slams shut, it stops the airflow coming out of the horn and the process starts over again. It does this at a set frequency that basically resonates back and forth, producing vibrational energy coming out of the horn. On this particular horn, it's a tunable model. So it has a set screw on the backside here that allows you to adjust this dampener on the backside diaphragm, which basically adjusts how far it can open or what frequency it resonates at, or its resonant frequency. A lot of times these are tuned to notes or musical notes on the spectrum, which makes them pleasing to the ear. Unlike some horns which aren't tuned, they're just loud. That's why some horns sound audibly better than other horns. Now, when this is oscillating, you'll notice it goes through this trumpet. Why is it shaped the way it is? It's shaped very similar to a megaphone, a old school record player, if you remember those. This particular logarithmic shape allows the sound energy to be gradually released into the air molecules. This makes it a much more efficient transition. Now granted, the bigger the horn and the better the log of the output, the louder the sound will be. But there is a limit, because the longer you make this, the lower the frequency gets. So this is a trade-off on how large the horn can be to how big it can get. How big it gets. For if you want really low frequencies, you would need a massive throat, almost the size of the studio I'm standing in, whereas smaller frequencies can be much shorter. So this is often why smaller horns will produce very loud noises, because they're operating at a higher frequency range and the horn's more efficient. But to get that girthy, guttural sound, that deep frequency that a lot of the bigger horns have, they need raw power. So they have a very large diaphragm on the back here. So see, it's quite larger than most horns, as well as a very large throat to get a good volume of air out. Now, why is the Nathan so much louder than almost all the other horns? Well, it has to do, like I said before, with sheer volume. It has 2 diaphragms inside producing sound energy, and has a 1/2 inch open port on the underside for a sheer amount of volume. I believe it uses 115 SCFM of airflow going through it. So I hope this helps give you a better understanding of why different train horns sound different, travel different, as well as have different loudness levels. It all has to do with the construction of the horn itself. Some have plastic diaphragms, some have stainless steel, some, like the Nathan, have 2 diaphragms, as well as some are made of metal, some are made of plastic. All affect the acoustical output of the horn, as well as frequency and output. So hopefully some of my results today help you realize that each horn is different and can function in different levels. Now, I told you all that because all those factors play into the 100-foot measurement that is the DOT standard. So what I'm going to do is I'm going to go ahead and put the chart up here beside me of all the horns at 100 foot. Now, the first thing you'll notice is all the values were done with the same meter, same A weighting, fast recording, loudness level. But at 100 foot, frequency starts to play a factor in it. So if you notice, some of the smaller horns, the higher pitch frequencies, don't quite travel as well as some of the lower frequencies of some of the longer horns. And other things too is Nathan spent a lot of time researching the particular notes it plays to make sure that they propagate properly and are heard loud across, well, whatever distance you hear it from. Whereas some horns that aren't tuned, the frequencies kind of seem to interact with each other and they don't quite output as well at distance. So one thing to point out is the Nathan K5 LA was still the loudest at 116. The Chrome Outlaw with the Marine bass came in at 111. And then we have the Shocker XL at 100 PSI, which was louder than the 200. Which we found interesting was the 145 was louder at 3 feet. So it may have something to do with the log design of the horn itself, and you put more air into it, the horn doesn't become as efficient at those pressures or velocities, so it doesn't propagate as well. Again, I'm not an acoustics expert, so this is a lot of my best opinion based on some of this data. Again, this is why I want to put all the data out there so you guys can look at it for yourself. Some interesting thing was too, like the Dixie horn fell down at 94.8 dB. And if you remember from earlier, the requirement states 96 dB to 110 dB classifies a train horn. So sadly, a Dixie horn doesn't qualify as a train horn, but I think we already knew that. One of the other things that's kind of interesting to point out as well is the maximum for train horns is 110 dB. The only one that came close to that, which actually exceeded it, was the Nathan K5 LA, and it's rated at 100 PSI for locomotive use. I was running it at 200 because I just wanted to get it to as loud as possible for tune. So it's producing 116, where its maximum rated output 100 PSI would be about 110 dB, which falls right in line with the regulations for train horns and their maximum allotted output. So all the details I covered today, as well as the full unboxing, full reviews, full sound clips of all of the horns, all 22 of them, will be on my website at djdlabs.com/horns. And if you have any questions, feel free to let me know in the comments below. I'll do my best to answer them. Now, I'm sure you guys had fun watching this video, for I had a blast making it. For I'm Doug with DJD Labs. Thanks for watching.